We're told that the coordinates of the endpoints of MN, line segment, are minus 13, 4, and 5, 4. What are the x-coordinate of the midpoint? So the midpoint would just be the average of these coordinates. So the x-coordinate of the midpoint would be average of minus 13 and 5. We don't have to find the y-coordinate because that would also be the average of those two, minus 4 and 4, because the question is asking about that. Minus 13 plus 5 is minus 8 divided by 2 is minus 4. That is answer choice G.
Okay, here we have passage 3. And let's have a look at it and see what we see. It doesn't look too bad. We've got a table that looks fairly straightforward. We do have 3 experiments. That's not so good. But the 2 graphs that we have here and here look very similar. And they have time in seconds, and absorbance and absorbance. So I like it when they have the exact same x and y axis. There's a good wee bit of writing here, so probably some information will be found here, because they generally don't write a bunch of stuff out there unless you're going to have to go there and look at it. So for this one, I will read to get an idea, because it looks like they're going to test us a little bit on what the actual test is about, because I've got a fair amount of writing about it. Alright, so transferrin is a blood protein. When in the presence of iron ions, Fe3+, each transferrin molecule will bind with 2 iron 3+, whatever. Iron chelators, it's italicized, so it's important, are used to remove excess iron in the blood, because they can bind with and thereby remove. Okay, so they remove iron from transferrin, the blood protein. Transferrin bound to the Fe3+ strongly absorbs light. So bound absorbs at a wavelength of 466 nanometers, but unbound transferrin and unbound Fe3+ do not. Okay, so bound absorbs, unbound, excuse my writing, does not. I'm taking down little notes for myself. 3 experiments were done using a colorimeter. Oh dear. Colorimeter? That's the best I'm doing. A device that measures a solution's absorbance of light to study the removal of the iron ions from transferrin by the iron chelators. Okay, so that's what tests are about. Let's go to the questions. When a colorimeter is used, a solution called a blank. Oh, I don't have a pen. I don't have a pen. I do have a pen. When a colorimeter is used, a solution called a blank, is first placed in the colorimeter to establish a baseline value against which other solutions will be measured. Which of the solutions served as the blank? So this is basically they're calibrating the thing. So we find solutions here. So I guess we're looking at table 1. And I'm thinking we've got a 0 and a 0, so that's a baseline would be you want it to get to 0 and then everything to be measured after that. So that is solution 1, answer F. That was nice and easy, thank you very much. In each trial of experiments 2 and 3, how often was an absorbance measurement recorded? So how often did they record things? If you don't know, this is a handy thing to know, because it does come up in a few questions. Maybe not just quite as straightforward as that one, but basically all these little dots and triangles, you see here it's all circles here, and then it's triangles there, squares there, I think it's diamonds here. Every time you see one of them, what it represents is that's when a measurement was taken. It's not there just to make the line look pretty. They are there to say this is when a measurement was taken. So what we have to do is how often. So we know that the figures are the same. I checked that before. It's the time in seconds, how often. So it's a time thing. That's 0 to 4,000. That's 0 to 4,000. So whatever we find in experiment 2 will be the same for experiment 1. So what do we have? We have 1,000 seconds here. We have 0 seconds here. So this is going to be 500. And we've got 1, 2, 3, 4 in between. So this is 100. Each little node, a little line here, represents 100 seconds. So we can see that up here, if we look at this, we have like 1, 2, 3, 4, 5 measurements within the 500 seconds. So it's 1 every 100 seconds. And that would be C. Question 14. What? Based on the experiments, as the concentration of the Fe3 plus bound to transferrin in a solution decreases, the absorbance. All right, we're going to have to go back to the intro. What does it say? As the concentration of Fe3 bound. Right, so the bound Fe3 strongly absorbs. So it bound really absorbs light. So if it's decreasing, then the absorbance is decreasing, right? Because it absorbs, bound absorbs, we've got that. If it decreases, then the what? Where is it? As the concentration of the bound thing in the solution decreases, the absorbs. That's the word I was looking for. The absorbance. I am going to lose my patience with this thing. The absorbance is going to decrease as well. So based on the experiments, and yeah, pretty much. I mean, it's increases only. No, decreases only. Probably varies, but with no general trend. Well, even if we look at the graphs, we can see that it's decreasing. This one goes kind of straight, but varies, but with no general trend, remains constant. It doesn't vary with no general trend. There is a general trend. The general trend is it decreases. I don't really like that question because of this here. But the only answer that makes any sense is G, so that's what we're going with. Right, I have to stop using my finger on the thing. Right, already. Based on the results of experiments 2 and 3, let me get rid of all this rubbish. Based on experiments 2 and 3, so we know that's going to be our first step, is to look at these two. The average rate of change in the absorbance during the Tren-Hoppe trial. So Tren-Hoppe is here, okay. So that's number 2, we've done that. Was closest to that observed during the trial with what other iron chelator and at what temperature? So it's basically saying this line here, what's it closest to? In experiments, this is experiment 2, so we're looking at figure 1 was experiment 2 and figure 2. So this one, it kind of ends, we'll look at the end point, it starts at point 8, it ends about 1. So this one ends about 1, let's see, at halfway at 2000, this one's about between 0.2 and 0.3. At 2000, this one's between 0.2 and 0.3, so it's this line here. So it's 25 degrees, says the ankulator, and at what temperature? So we know it's 25 degrees. That's going to get rid of B and D. And then absorb. It doesn't tell me. I'm going to read the experiment. I'll increase this for you. And it says, here it's right here, the deferoprone trial. So it's deferoprone at 25 degrees. There it is right there. It's C. 16. Suppose that you think would learn. That's the third time I've done it. Oi! Right, suppose that in experiment 1, 10 millilitres of solution 2 had been mixed with 10 millilitres of solution 4. After the solutions were incubated, if the absorbance of a sample of the resulting solution had been measured at 37 degrees Celsius, it would most likely have been closest to which of the following? So this is called an interpolating question. It's asking you to find a value between two other values. So the value that we're looking for isn't going to be found in the table. We're going to have to kind of calculate it from the two other solutions. So first thing we do, we find experiment 1, and that's here. So we're looking at table 1. Then we have to find solution 2. The second step, we find solution 2. Solution 4, that's that one. So we're looking at these values and these values here. If the absorbance of a sample of the resulting solution had been measured, so we're looking at this at 37 degrees. Yeah, they're at 37 degrees, so we'd have to worry about temperature. It would most likely have been closest to which of the following? So we're looking at this here and this here. So it's between 0.35 and 0.76. So look over the answers. 0.35, no, too low. 0.64, yes. 0.76, too high, so it's G. Last question. Based on the description of experiment 1, okay, so we're looking at here, and of a colorimeter, you know what I mean, the material making up the test tube that was placed in the colorimeter most likely, so it's asking the material making up the test tube, so it's asking about the stuff they put in it to calibrate it, that was placed in the thing. Right, absorbed little or no light, strongly absorbed light, reflected all light that was less than 466, reflected all light. So they're talking about this here. What did it do? When they placed that in there, what was it doing? So the experiment, a test tube containing a sample of solution 1 was placed in the colorimeter. The colorimeter was adjusted such that the absorbance readings measured at 466 for solution 1 at 37 degrees would be 0. So they want no, they don't want it to absorb any light, right? Because if it doesn't absorb anything, then that means it's at 0. And then any light that's absorbed after that, we know that it's from 0 on kind of thing. So they want it to have no, so it would be A. I'll look at the other ones, but it's A, I think. Strongly absorbed light, no. Reflected all light, they don't want to reflect anything. It's a test of absorbance. So it would be A. They want one that absorbed no light, and then they can be safe that if anything does absorb light after that, that it's, you know, it's coming from a point where it starts at 0. All right, so that is A for 17, and that's the end of that passage.